Determine whether the quadrilateral ABCD with vertices A, B, C, and D as given is a parallelogram. For this question, there are three methods that we can use. The first method uses the side lengths of the quadrilateral. For this, we have to use the distance formula to calculate these side lengths. The idea here is that if opposite sides are equal, then it's a parallelogram. Let's first plot the points and then the quadrilateral. Point A at 1, 3, point B 4, -2, C 0, -3, and D -3, 2. Let's first figure out the length of line segment AB. To do this, we simply substitute into the distance formula. 4 minus 1 is the difference in the x-coordinates, and -2 minus 3 is the difference in the y-coordinates. This gives us the square root of 34. Let's do the same thing for the opposite side, CD. Again, using the distance formula, -3 minus 0 is the change in x-coordinates, and 2 minus -3, the change in y-coordinates. Again, we get the same result, the square root of 34. We have to do this for the other two sides. First of all, side BC, 0 minus 4, the change in the x-coordinates, and -3 minus -2, the change in the y-coordinates. This gives us a result of root 17, and its opposite side, AD, again, the distance formula, -3 minus 1 for the x, and 2 minus 3 for the y-coordinates. Again, we get root 17. Note here that the opposite sides are in fact equal. We can therefore say, yes, this is a parallelogram. Method 2 will use the midpoints of diagonals. For this, we will use the midpoint formula. The premise here is that if the midpoints of the diagonals are the same point, then it must be a parallelogram. Using the midpoint formula, first of all, for the diagonal AC, the x-coordinate will be 1 plus 0 divided by 2. Note this is the average x-coordinate between points A and C. And then the average y-coordinate, 3 plus -3 divided by 2. This gives the point 1/2, 0. We then look at the diagonal BD. The x-coordinate, 4 plus -3 divided by 2. And the average y-coordinate, -2 plus 2 divided by 2, also gives the point 1/2, 0. Since these are in fact the same point, we can say that this is a parallelogram. And the final method, we can now use the slopes of the sides. To do that, we will use the slope formula. The idea here, if opposite sides have the same slope, then it must be a parallelogram. Let's figure out the slope of line segment AB. We have the rise, -2 minus 3, divided by the run, 4 minus 1. This gives a slope of -5/3 for line segment AB. Looking then at line segment CD, opposite to line segment AB, again figuring out the slope as y2 minus y1 over x2 minus x1, we get the exact same slope, -5/3. We now must look at the other opposite sides. First of all, the slope of line segment BC, the vertical change, -3 minus -2, divided by the horizontal change, 0 minus 4, gives us -1 over -4, or 1/4. The opposite side, The slope of line segment AD, again, will be y2 minus y1 over x2 minus x1, also equal to -1 over -4, or 1/4. Again, note that the slopes of both sets of opposite sides are equal. That means that this is indeed a parallelogram.